Professor Christopher Bay, thanks so much for coming back onto Evolution Soup all the way from your home in Honolulu, Hawaii. You are Professor of Anthropology at the University of Hawaii at Manoa, and your main interests center around the human evolutionary record in East Asia and all its intriguing species, especially those discovered in recent years. Last time we covered the Asian hominin Muddle in the middle, including the new and unifying species Homo juluensis, and then a comprehensive deep dive into the history and mysteries of Peking Man. Today we'll be returning to the world of Homo erectus and a fossil that's placed the species in Asia much earlier than previously thought, the Yunxian skulls. Welcome back to the show, Chris. Well, it's been a year since our last interview, and I know you travel quite a bit, especially to China. You've been to quite a few places since we last spoke, including a recent visit to Iceland, isn't that right?
Good morning, Mark. I just want to thank you for inviting me back onto the show. I'm more than happy to talk to you about all of this stuff going on in China. And yes, I just returned from Iceland last week. What happened is I was invited to serve as an opponent on a PhD student's dissertation defense. And so, as part of their process, they actually invite the opponents to Reykjavik, the University of Iceland, for the actual defense. So it was actually a big process and stuff. But since I have never actually been to Iceland before, I had really had no idea how to get there from Hawaii. And so it ended up taking me like 40 hours to get there. So I ended up staying for a few more days because they actually had the Iceland Geosciences Society conference there at the University of Iceland a couple of days after the students' defense. And so I ended up presenting a paper there as well for that. So I got to learn a lot about glacial moraines and all that good stuff in a place like Iceland. So it was actually a really great trip to be there. Yeah, and it has been a year since we've talked. So I have been to China over the last summer. I was doing field work in Inner Mongolia. I visited Mongolia as well, and I set up a new project in Mongolia, kind of like following in the footsteps of Roy Chapman Andrews, which we've talked about earlier. And then last fall was also pretty busy because I was invited to go to Paris for a conference on the Acheulean. The Acheulean hand axes is a big area of research in Paleolithic archaeology, so I was invited there. And then since I was in the area, I visited a close friend who is currently the Korean ambassador to Croatia. So I visited him in Zagreb, and what's interesting is that there is the uber important Krpina Neanderthal Museum there. And so we had a chance to visit that museum and see everything that's on display there because it has, I think, the largest collection of Neanderthal fossils in one cave site. So there was that, and then I was invited to give a couple of talks at the University of Toronto and University of Michigan as well. Some of it was on my research, and then as you're aware, I was also a Korean adoptee, and so one of the talks I was invited to give was actually about my life story and stuff. So about being a Korean adoptee. So yeah, I've been pretty busy running around the world actually. So it's good to be home.
Today we'll be diving back into the ever-evolving story of ancient humans in Asia. But first of all, could you refresh us on the timeline of hominid discoveries in China, the techniques that are used, and why recent fossil finds are challenging early ideas?
Sure. As part of the previous two interviews that I did for you, we talked a little bit about this, but just as a brief refresher, Asia was once considered to be a center for the origin of modern humans, right? So if you were to look for a so-called missing link, so to speak, Asia was very prominent, up through there, the late 1800s and into the early 1900s. So this is the reason why Eugene Dubois was drawn to Indonesia to look for the missing link there. Roy Chapman Andrews thought, he would be able to find the missing link, in Mongolia, and so that led to the Central Asiatic expeditions. We now know that hominids are present. Were present in places like China, going back as far as about 2.4 million years ago, right? And over the course of the past 2.4 million years, you've got at least a number of different hominids roaming around Eastern Asia. So Homo erectus, Homo juluensis, Homo longi, Homo neanderthalensis, uh, Homo floresiensis, Homo luzonensis, and of course Homo sapiens as well. One of the problems, though, in Asian paleoanthropology traditionally is trying to figure out when the FAD and the LAD are. So the FAD is the first appearance datum, and then the LAD is the last appearance datum. So basically, you want to try to figure out when do these hominids first appear in the region, and then when do they disappear in the regions? At least locally extinct, if not permanently extinct. So a good example of these dating problems in Eastern Asia is a site called Yuanmo in southern China, where they found two incisors that are clearly represent Homo erectus. The problem, though, is that they were found on the surface, and so it's not clear exactly the relationship between the dated sediment and the fossils. And we actually have pretty good dates for the UNMO sediment, but we don't really know if the teeth actually date to that time period there, right? So, and this is a problem that is associated with almost every Homo erectus fossil in Indonesia as well. Because a lot of these are from the late 1800s, early 1900s, and then people going back 100 years later trying to identify the exact context from where the Homo erectus fossil was found is very difficult. So it's a problem that has plagued Asian paleoanthropology for a long time. And dates are constantly changing. A good example of this is a site called Gongwangling, which is also associated with a Homo erectus fossil in central China. This was paleomag dated to about 1.1 million years ago, and this was published way back in 1989. And that became the standard date for that site. And then what happened is that about 10 years ago, a different research team went back and they did a new paleomag redating of the site, and they pushed the date back to 1.6 million, right? And the new date wasn't contested, and this is now, up until the publication of the Yunxian Homo erectus fossils, which we'll talk about, was considered to be the earliest Homo erectus fossils that were found in situ in China.
Well, the age of the three Yunxian skulls found between 1989 and 2022 has long been debated, though are accepted as being around 1.1 million years old. New dating techniques, however, have placed them even further back in time. So, what is the story of the Yunxian skulls?
Yeah, so the Yunxian site is actually really interesting. It's a site that was found by local farmers. They were digging, their crops and stuff like that along the Han River in the late '80s, and they started to find fossils, in the ground. And as I mentioned earlier, in China, when farmers find fossils, they are required to report them to the local authorities. And so one thing led to another. And then researchers came out from the Institute of Archaeology, from there. And so they started excavations in the late '80s and then early '90s. And In addition to finding two really squashed hominin skulls that eventually were assigned to Homo erectus, they found it in association with thousands of other vertebrate fossils and lithic artifacts. So the site became really, really important. The problem with it, though, is the Homo erectus fossils were really squashed. It was very difficult to be able to say anything conclusively about them. And then the age was always in question. And so the age actually ranges between 1.1 million and 600,000, as recently as 600,000. And so people who are trying to lean towards, placing these as more advanced Homo erectus or archaic Homo sapiens had a tendency to use the more recent dates, while people who said these are more traditional, like traditional Homo erectus, had a tendency to lean more towards the older dates. So, uh, the initial analyses were of the hominid fossils themselves were conducted by Li Tianyuan and the late Dennis Etler. And they published a paper in Nature in 1992. And then basically it kind of like died out for a while. Nothing new was going on, and then Amélie Violet from Paris, from the Natural History Museum there, and her colleagues published a really seminal paper in 2010 where they reconstructed the skulls of through virtual reconstruction of the skulls of the Yunxian fossils. And the conclusions that were drawn by Li Tianyuan and Dennis Etler and Amélie Violet and her colleagues were that these are clearly Homo erectus fossils, representatives of Homo erectus. In 2022, they had new excavations at the site, and they discovered a third fossil, Homo erectus fossil. And so this is called Yunxian 3. The first two squashed fossils are Yunxian 1 and Yunxian 2. Yunxian 3 is under study right now by researchers in the IVPP in Beijing. So we're waiting to hear, to see what they actually, how they interpret the information. So that's put on the side. And then what happened last fall is that there was actually another reconstruction of Yunxian 2. And this was published in Science. And it's interesting because they then incorporated that into a phylogenetic analysis, and they found those researchers found that Yunxian 2 can be closely linked to the Harbin skull, which is the type specimen for Homo longi. And so they argued that Homo longi, the split between Homo longi and Homo sapiens can go back to Yunxian at 1 million years ago, right? So obviously, it raised a lot of questions by people in the research community because of the phylogenetic analysis. People that have actually looked at the reconstruction, the virtual reconstruction, though, have said that maybe there were things that they tended to maybe overemphasize a little bit, and maybe didn't emphasize some other aspects of the morphology. So there were questions raised about that. AI reconstructions is a good example. I'm associated with the new species Homo juluensis, and if you go online and you look at some of the AI reconstructions of Homo juluensis, they all look very Asian, right? So and they all also look very clean cut. So it's actually pretty funny when you look at some of these reconstructions. So maybe it's not that surprising that Yunxian 2 has a tendency to look a little like the Harbin skull, but it'll be interesting, And then the other aspect of the phylogenetic analysis that came out last fall that included this is they didn't actually include the Shujiayao fossils, which are actually the type specimens for Homo juluensis. And so it'll be interesting to see how how if we add these other factors or these other components into the phylogenetic analysis, how it would actually look there. But it is interesting, and so the jury's still out regarding a lot of the interpretations with this stuff. I will say, though, as soon as this paper came out, last fall, there are still a lot of people in places like China that are, hardcore multi-regionalists. They want to find the earliest, trace the earliest, Chinese back in time to a place in China. And so they latched on to the Yunxian fossils and, this paper and said that clearly you've got Chinese origins going back at least 1 million years ago. Uh, and so these people, also latched onto our study as well, and they came out almost, immediately after we came out with our find, and we said that Yunxian probably goes back to 1.8 million. So they were all, multi-regionalists were really happy, right? Because then they said that we can clearly trace, modern Chinese all the way back to at least 1.8 million years ago now.
Just recently, February 2026, you published a paper proposing a new age for the Yunxian skulls. Your team used a technique called cosmogenic nuclide burial dating. Chris, how does this new technique work and why is it so useful?
Yeah, more than happy to talk about our paper, in this context. I do want to first shout out though to my collaborators, Hua Tu from Shantou University, Daryl Granger from Purdue University, and Guangjun Shen from Nanjing Normal University. As these guys are the actual cosmogenic burial dating specialists. The samples themselves are prepared in China, but then they're actually shipped to Purdue University, to Daryl's lab there, and then he has his people actually run through all the analyses and stuff. Basically, the idea is that beryllium dating works when cosmic rays are embedded in the quartz, and they're constantly being embedded in the quartz. And then the trick, though, is that the quartz needs to be buried. So the rocks actually need to be buried. And then when they're uncovered, unburied later on, by measuring the amounts of aluminum and beryllium in the quartz, one can get a pretty reliable radiometric date that way. The clock can go back as far back as 5 million years, and this technique has actually been proven to be very, very useful, very reliable in areas like South Africa, where there has been little to no tectonic activity. So a radiometric dating method like argon cannot be used, and it's been a problem traditionally in a lot of the South African sites. Because they couldn't figure out how old they were other than using faunal correlations. So the first time that cosmogenic burial dating was used in China was actually, looking at the Zhukotian Locality 1 Peking Man site. That site was traditionally dated to between 220,000 and 550,000 years ago. And, up through the early 2000s, that was basically the dogma, right? That is basically what the dates that everybody accepted for Homo erectus in China at locality 1. But the cosmogenic burial dating analysis said that the deposits at Zhukotian locality 1 can actually be pushed back to 400 to 800,000 years ago. So basically, you're adding between 300 and 400,000 years to the deposits at locality 1. Initially, there was a lot of skepticism about it, but as time went on, the dates at between 400 and 800,000 years ago are now accepted for Zhukotian locality 1. Another site is a site in northwest China called Pulu, where the dates there actually confirmed the argon dates there. So basically, the method was proven to be very very viable in China. Another good example is the Gongwangling site, which I mentioned earlier, that originally was dated to 1.1 million years ago, and then by paleomag, and then a more recent paleomagnetic analysis pushed Gongwangling back to 1.6 million years ago. A year later, they applied cosmogenic burial dating analysis to the Gongwangling sediments, and they actually came back with an age at exactly the same 1.6 million. So in that particular case, the paleomag, which is kind of a relative dating method, right? Because you have to line it up in the sediment, so there is some subjectivity there. And the radiometric from the cosmogenic burial dates dating method, they line up almost exactly. So that was good confirmation there. Probably what really caught a lot of people by surprise is the application of the cosmogenic burial dating to a site called Shihodu. And Shihodu has been known in Chinese paleoanthropology, Paleolithic archaeology for a long time, but it was never really considered to be a real legitimate site because the artifacts were considered to be geofacts. And it had dates ranging between like 1.2 and 1.8 million. But the cosmogenic burial dates for the site came back at 2.43 million. And one of the advantages, though, is that because of the renewed field work, they actually found in situ artifacts that are real. They look really good. I've seen them myself, and they look like legitimate artifacts, right? And so suddenly you have the earliest peopling of China being pushed back to 2.43 million years ago, and this is thanks to the cosmogenic burial dating analysis. So our study, because of the questions with the Yunxian dates, they relied on early paleomag and then ESR, which is another radiometric dating method, but the ESR dates came back to be really young, and then the paleomag came back at about 1 million to 1.1 million years ago. The cosmogenic burial dates that we came back with, push everything back to 1.8 million. So it's interesting because suddenly Yunxian is now at about the same level in terms of the age with Gongwangling, just slightly older, right? But people may not realize that the fauna is actually very similar between Gongwangling and Yunxian. So if you're going to accept Gongwangling based off of the paleomag and the associated fauna, then there's really no reason not to accept Yunxian at 1.8 million, simply because the fauna correlations seem to match up well. And the cosmogenic burial dates between Gongwangling and Yunxian also seem to match up pretty well. It's interesting because one of the immediate comments that came out after our paper was published last month is that the dates don't match the morphology of the skulls. So, if you say that, then it implies that the dates are wrong. But if we flip the argument, we could just as easily say that the reconstruction of a badly damaged skull is wrong, right? The dates are right, but there's a problem with the morphology. And this argument is reminiscent of the criticism where the early dates for Shihodu were initially published at 2.43 million. Some of the critics of that site and those dates said that if the dates are right, then these are clearly not artifacts. So the whole process seems to be a bit backwards in the way people are asking these types of questions and stuff. So, but my guess is only time will tell, regarding getting resolution regarding some of these questions.
Well, I guess the big question is, how does this change our view of not only Homo erectus, but the out of Africa model as well?
Yeah, it's obviously directly related to this. If one thinks about the traditional out of Africa one model, it posits that Homo erectus, and had to have been Homo erectus, which I'll talk about in a second, moved out of Africa at about 1.8 million years ago, and this was in part supported by sites like Dmanisi, the sites in the Neanderthal Basin in northern China, and then the sites in Indonesia as well. But we can really challenge this traditional model based on two areas. One is a lot of there's a growing number of sites, that actually predate 1.8 million years ago, 1.9 million years ago, when Homo erectus or Homo ergaster, first appears in Africa. Good examples are Shihodu at 2.4 million in China. You've got Shangchuan also in China, not far away from Shihodu. That goes back to about 2.1 million. You've got sites in the Levant and in South Asia as well that have dates that are proposed to be older than 2 million years ago, right? So this means, either that we need to consider pushing the origin of Homo erectus or ergaster back to the Pleistocene transition, where you've got Homo erectus or Homo ergaster evolving in Africa, and then during the Pleistocene transition about 2.5, 2.6 million, and then moving out at that point. The alternative is that we need to think about or consider maybe it's a different hominid that actually moved out of Africa initially. And the reason why this latter part's actually come to become a real big question is because a lot of our reconstructions of Homo erectus, the body shape of Homo erectus, actually relies on the Narikatomi boy, WT 15,000, and and Narikatomi boy, was between about 8 and maybe 12 or 13 years old when it died, right? And it's because it's a boy. Everybody knows that you don't really hit your final growth spurt until your later teens, right? When you hit high school. So Narikatomi boy, it's estimated that he could have grown to somewhat around 180 centimeters, right? So about 6 feet tall, or 5'10" or something. So for the first time in prehistory, we have a hominid that falls within the body size range of modern humans. And so that was part of the argument that once you have hominids that fall within the body size range of modern humans, then home ranges can expand as a result of that. And so that became dogma. Nobody really tested it, but over the course of the past 10 or 15 years now, people have been raising a lot of questions about this because they realize that Narikatomi boy is actually an anomaly compared to other postcranial remains associated with Homo erectus. A good example of this is Karen Babb's recent work. She appeared on Evolutionsoup recently, right? Talking about her recent paper and the reconstruction of the Dan 5 Homo erectus skull from Gona in Ethiopia, where they actually found that there were characteristics or features that could be associated with habilis. So other people have, Susan Anton, Emily Middleton, Emily Viole as well has talked about this, but we're finding out that there's actually a lot of overlap between erectus and ergaster and habilis and rudolfensis. And another good example of this is, the Dmanisi fossils. The comprehensive report was published in 2013. It was quite clear that you're not looking at typical Homo erectus fossils at Dmanisi, and so the researchers there, suggested that maybe these guys should be called, Homo caucasi or Homo georgicus or both. There was actually a recent paper, that focused in on the dentition from Dmanisi, that argued, that you actually have two species, caucasi and georgicus at Dmanisi. So it seems like because of the amount of morphological overlap between erectus and these other groups, that maybe we need to consider alternatives rather than just having an individual that's in the body shape range of Narikatomi boy moving out of Africa. Maybe something smaller like habilis actually moved out of Africa, or maybe even an australopith. It can't be completely discounted at this stage. But regarding the Yunxian paper and how it fits in all this, these new dates at 1.8 million serve to anchor the first appearance datum of Homo erectus in Eastern Asia, and so it gives us something that we can use now to say that okay, we have Homo erectus in Eastern Asia, in central China at 1.8 million years ago. So It'll be interesting. This is the date of the week, right? Until a new dating study comes out, so which may actually end up pushing it back or pushing it forward in time. But that's part of the science that we do, and it's actually good that we have this date out there, and now people can examine it in more detail.
Well, these new dates are certainly going to ignite a lot of conversation in the scientific community, and hopefully, we can have you back on the show soon to update us on the changing face of ancient Asia. So, what's next for you, Chris? What upcoming projects can you tell us about?
Right now, I'm just going to finish out the semester, and then I'm planning to go to China for more field work for about a month, and maybe set up. Hopefully, if the funding comes through from Mongolia, we'll also head to Mongolia for a little bit as well. Uh, one of the things with Mongolia is that a lot of the projects there focus in on the late Pleistocene and the Holocene, right? Uh, but I'm more interested in the earlier part, the earlier prehistory, right? So looking at the Middle Pleistocene or the Chibanian, and maybe even the early Pleistocene, because if you connect the sites from, say, Dmanisi and then the Neowan Basin, they clearly would have moved over a northern route. So there's probably going to be some remains in northern Asia and places like Mongolia if you look hard enough. Another project that we're working on right now is the Mystery Ape project. Hopefully, you'll hear more about that soon enough. If and when the project finishes. But that's really about the site Longgupo in southwestern China, where they published a partial mandible and some teeth, and they said that it might be Homo habilis, right? And this is way back in 1995, and so what happened is that as soon as that paper was published, people came out of the woodwork and started criticizing and saying that it's not actually a hominin fossil; it's actually an ape. And so people suggested maybe it's Lufungpithecus, and then other people said it's actually probably a new species, maybe a new genus. So my collaborators and I are now actually looking at that to see if what's there and what may come of that. So um, I'm also working on my next book, tentatively entitled "In and Out of Asia Again and Again," because it's actually come up a lot. You think about the earliest peopling of Europe. Right now, it seems like it's probably about maybe between 1.4 and maybe 1.6, maybe 1.7 million years ago. But if the earliest people of Asia goes back to 1.8, or goes back to 2.4, 2.5 million, you're looking at almost a million-year gap between Asia, the peopling of Asia, and the peopling of Europe. So the question, this came up during the Ashley conference that was held in Paris last fall. But why is there such a substantial chronological gap between the earliest peopling of Asia and the earliest peopling of Europe? So this is stuff that I'm working on now with my collaborators, but it's also going to form some of the core areas of my next book. And as a precursor to this, I'm working on an invited chapter with some of my graduate students for the second edition of the Handbook of Paleoanthropology. That should probably appear later this year or next year. So there's actually a lot going on with a lot of different projects. So it's all good.
Christopher Bay, thank you very much indeed.
I just want to say thanks, Mark. It's been a pleasure. It's been a pleasure to be on your show again, and more than happy to talk to you about all this stuff. Paleoanthropology is a very exciting field where every week there's something new coming out, so it's always changing.